Good morning, everyone. So, first of all, it's really an honor to be here, and I thank you all for your time and the opportunity for us to share our entire experience as well as the use cases that we had. Right. So we had been using Redis for almost 7 years, and there have been quite a ton of use cases. But for today's talk, I just want to keep things simple and just share with you the power of simplicity and exactly how the simple things they can change things around, like and specifically using Redis, right? So. So myself, Redis Manvar, I'm Chief Technology Officer at Holidayme. So Holidayme is an online travel agency which was founded back in 2013, right? And so we have online customizable holiday packages, hotel flights, and recently we also have Umrah packages, right? We have our main presence in Middle East, and just over a year ago, we started our operations in Southeast Asia as well. Right. So earlier, before we knew Redis, so actually we used to use Memcache, and it was back like around 2013, almost same time. We wanted to have a Memcache cluster. So I went ahead with AWS and started creating an Elastic Cache instance. So at that instant, I realized like it gives two options. One is the Redis as well as Memcache, and it got me curious to look at exactly what Redis actually is. And just out of sake of curiosity, I spin up a Redis instance on Elastic Cache. And practically that was the day and today. So our love for Redis, it keeps on growing. Another thing was like at that instant, we were using Redis just from a pure caching perspective only, right? Simple key value store. But as over the time period, we started exploring more and more data types which Redis has to offer. And eventually, it was we were able to use Redis as our primary data store altogether, right? Over these couple of years, there were quite a few use cases that we had where we had created some kind of functionality on top of Redis itself. And it was later that we realized that quite a few functionalities, they are already available as a part of modules on Redis. So it was in 2019 itself that we decided that we'll go ahead with Redis Enterprise and start using those modules. And Redis Search was our first module that we started using. Right. One bigger use case is using Redis for logging. Now, as soon as I talk about Redis being used for logging, so most of the people, they either get confused or they get curious basically how you can connect logging with Redis. Right. So, and that's pretty much the agenda that I have right now, which is the need of a new logging framework, specifically in a serverless world. And when I'm saying serverless world, so it is more around function as a service, right? Why, where, and how the Redis fits in, right? And in the last, I'll share some of the benchmarks or some of the stats and our future goal. So in around late 2017, 2018, so we were in a process of moving our entire architecture from monolithic to microservices, and we were much more inclined to use function as a service, and we chose Lambda function. So to migrate our entire monolithic using microservices framework. So that was the key moment. So actually, like we did quite a few POCs, and we decided that there's one small application that we have, which would be easier to move into Lambda, and we can try that out. And as soon as it was done, we were kind of curious to see exactly how it performed. And it was, I would say, it was a fortunate surprise. The APIs that used to work close to 800, 700 milliseconds earlier, ironically, it was taking close to 1.5 seconds, right? And why do I say fortunate? Because that was a kind of moment which got us thinking exactly what's going across wrong. Because practically the entire code, everything was same. And there was also one instance in time where we thought probably Lambda is not that performing, right? But when we dig down into it, so we got to realize that actually the main problem that we are having is the way that we are logging, right? So I'll go into it a bit more details, but first I'll look into exactly how do we log into servers. So when you have your normal EC2 instances where you have web applications deployed, so there are quite a few common logging practices that you have. So either you are creating some log files which are being saved locally, and as soon as you reach some kind of size threshold or the time threshold, so you have a cron job which picks up those logs and does some kind of pre-processing and moves that across to data store. Or you have some kind of agents running into the background, or probably some kind of daemon service, which open up some kind of TCP or UDP port or some other protocol where your application can directly send those logs across. Now, the thing here is, so practically your the applications which are there, so they don't have to look much around the latency which can be created by creation of logs itself, because everything is happening locally, right? So with servers, so the best thing is exactly you have access to the entire operating system, right? So you can modify or tweak some settings, you can install some kind of background processes, you can make use of local storage, and you can have like the services which can do the pre-processing, and they can offload the heavy lifting of the logs altogether and send them across, so that your application can spend more time in terms of serving the business needs rather than generating logs and sending those across. On the contrary, when you look from a function as a service perspective, first of all, you don't have access to the operating system. You, like in most of the scenarios, you won't even get to know what is the kind of operating system your function is running on, right? And definitely you can't tweak those settings across. So the thing which comes across is like they do have a local storage, but that is something which isn't guaranteed as soon as your invocation or the instance gets completed after the execution. So you don't have that kind of reliability that that local storage will still remain or not, right? And practically, you don't have a background service where you can push those logs across, which practically means each and every single log that you are generating across, that needs to be transferred to its destination by that function itself, right? So now your function has to do two things. One, definitely serving the business logic, as well as sending those logs across, right? So the question comes across is exactly then how do you log in serverless world with function as a service? So there are quite a few options. Like in our case, our entire stack is onto AWS. So CloudWatch and X-Ray is definitely one of the options. But we had a peculiar case over there. So CloudWatch, it has a limitation of 256K. You can't go beyond that. And you will definitely wonder, like, why do we want to have logs more than 256K? So in our business, so many times it does happen that we have to rely on third-party suppliers, right, for the inventory or for the content, for the hotels, or for the holiday package that we are creating. So we are required to save those as a logs for a later reference, right? And sometimes these responses from these APIs, they can go even to 4 meg or even 5 meg, right? So that's why the need which comes across as like our logs at some instances can be more than 256K. Right. So that's obviously that was not an option for us. So second thing comes across is you have multiple third-party solutions with the logging framework, and they provide multiple options for using HTTP endpoint or probably some TCP or other protocols where you can send those logs across. But still, it has a problem. That first of all, it has a high latency, as well as even they do have a like size restriction. So the third option which we came up with was using Redis and Redis list for that. Now, why using Redis list, right? So first of all, Redis does have a very low latency altogether. There's no size restriction, and it is pretty reliable, right? So we had been using it for over 6 years at that instant, and we didn't have any issues. So this is now what our structure looks like from a Lambda perspective. So each and every single Lambda function, so they can use our push command and send those logs across to the Redis list, where we have some kind of background service running on a different instance, which issues lpop commands. It pulls all the logs from the Redis list, does some kind of ETL, and push that to data store. So the difference which happens over here is, so there are two things. First of all, we have a very low latency while sending those logs across to Redis list, right? And also another thing is we don't have any restriction on the size. So what did it happen? So I'll go back to the initial use case itself. So when we mentioned that our overall latency had grown up when we moved to Lambda using our previous logging framework. So actually, it was close to like 120 milliseconds additional latency, which was introduced by that logging framework. But as soon as we used Redis, that was brought down to around 25 milliseconds, right? And even when I say 25 milliseconds, so Redis in itself was taking less than 1 millisecond to execute, like around 15, 20 milliseconds was the network latency that we were having, right? So during our initial days, like when we completed this POC and we were moving our entire logging framework onto Redis, so at that instant, we were using or we were having ingestion of more than 15 gig per hour, which was close to like 600 operations or 600 logs, which were getting pushed on every second basis to our Redis instance. Also, the best part, like even from a business perspective, was even though we were running a new Redis cluster, right, and practically it was not additional cost altogether, right, and actually it lowered down our cost. So how actually that happened? So if we look from a microservices standpoint, so this is just one simplistic version of our hotel service, right? One of the microservices. So in a microservice, you end up having like one microservice dependent on another microservice and so on and so forth, right? So in this use case, if we see the middle line, right? So we have the situation where before able to deliver the hotel listing to the end customers. So there are at least 4 different microservices which are running into the backend, and we have to keep on waiting one-on-one. Now, just imagine like if you have just 25 milliseconds as a latency which is being utilized by a single Lambda function to send those logs across. And sending a log across is practically not a business benefit, it's just from a developer or analysis standpoint. So it will have a ripple effect altogether, right? So as soon as you have 25 milliseconds on your very left, so it will take 25 milliseconds for the logs. The function waiting for it definitely has to wait those 25 milliseconds, and additionally, its own 25 milliseconds for the submitting the logs what it has it is being generated. So the latency keeps on adding. So just to look at it, like if you have a log latency of 25 milliseconds, so practically it will impact your end user by 120, 125 milliseconds altogether. And so this was something that we had. But on the contrary, if you have 117 or 120 milliseconds on a single instance, it may result to close to only 600 milliseconds altogether. So there are 2 problems with it, right? So it may not seem like 25 milliseconds or 100 milliseconds not a huge difference altogether, but practically what happens is, first of all, your end user, they have to pay the penalty of you generating those logs. At the second instant, in function as a service, or practically from a serverless perspective, you get billed for every 100 milliseconds, right? So if we just look at this example itself, in the first case, in case if it is 25 milliseconds, so we have to pay 2 units additional, because AWS Lambda, they charge on 100 millisecond basis. So we pay just 2 units additional. In the contrary, while if it is 170 milliseconds, so we were paying like 6 units additional. So that was like practically like 3 times the cost saving. So this was the main difference, which actually caused us, like even after using the Redis instance for collecting the logs, still the cost was much more cheaper overall. So these are just some of the stats from that time. Like so on your left, it is the EC2 instance on which the Redis Enterprise cluster was running. So that is the traffic that we had. So probably the numbers, they won't look much clear here. And on the right-hand side, so it is like number of operations that we are having on per second basis. So at that instant, it was close to like 600 write and 600 read, which was close to like 1,200 operations per second. And if you can see, the latency almost all the time, that was less than 1 millisecond, right? And this was a huge thing. So practically, like this was the main reason how we could use the simplicity of list in our logging framework and practically like making things much more simpler for us. Now, managing the list in itself, like so it does come with its own challenge, specifically from a perspective like once you have popped out a message, then the failover instance is something that you have to manage into your code, and there's quite a lot of things that you have to do. So that's why from a future perspective, we are much more keen and interested in trying out the disk module. And that's pretty much it from my side. So thank you all for your time.